Hi class, so we are continuing this video, no? So this part of the video, and our next video will be the most critical part in this video series, no? Kasi uh, we are going to first check the adequacy of our design footing against moment, no? And on the next video we are going to design, no, the reinforcement, no, uh, nung footing natin. Now we are going to reinforce our footing now with steel bars. Pero of course, no, I would like to go back first, no, on the basics from reinforced concrete design, no, just to give you a little background how did we came up with uh, this or that, no. Kasi syempre uh, it's much better if you know the basics, no. So uh, it would be better, no, if you know everything, no, about reinforced concrete beams, pero if you don't have any background, no, siguro this, I hope this will be a big help, no. Okay, so let's start, no. Okay, so let's say, no, uh, we have a beam, no. So we're going back to uh, what we've learned from reinforced concrete design, no, in order to see how are we going to check, no, our design footing, if it's adequate against bending moment, no. So going back, no, from your reinforced concrete design, no, we have, assuming we have a beam, no, typically, no, any point doon sa beam na yon, no, is subjected to what we call shear force and bending moment, no. So sa bending moment na yon, no, ah bending moment na yon, no, let's say we consider uh, a point, no, wherein the bending moment is maximum, and look at this, no, we assume that this is how a reinforced concrete beam looks like, no. So we have here uh, a base width, no, B, no. So let's say this is your letter B, no, and then we have a height, no, which is H, no, and we all know that concrete, no, are weak in tension, no, kasi nga from your strength of materials, no, bending moment causes both tension, no, and compression at a certain section and at a certain point in the beam, no. So meron tayong tinatawag na compression fiber at saka tension fiber, no. So yung compression fiber is the region wherein uh, compression, happens, no, while tension fibers where tension happens, no. So uh, saan nanggaling yon, no, sa bending moment, no. Kasi whenever moment, no, whenever meron tayong upward bending na tinatawag, no, kapag yung moment natin, no, is making the beam smile, no, we know that uh, we know that um, the top fiber, no, so the top fiber, yung taas na fiber niya, experiences compression, while the lower fiber experiences tension, no. So ano ang what separates the tension and the compression fiber? It is what we call the neutral axis. Okay, so this is, let's say this is your neutral axis, no? So neutral axis. Okay, so let's say this is your neutral axis, the one, let's say this point, no? Let's say this point is your neutral axis, no? Let me erase that. Okay, no? So that, okay, that above the neutral axis, no, the beam experiences compression, while below the neutral axis it experiences tension, no, due to the positive bending moment, or the one that causes upward bending, no, or the one making the beam smile. Okay, no, so that is the concept that we've learned from your strength of materials, no? So, no? Uh, we all know that uh, we all know that yun nga, sabi ko nga kanina, no? We are talking about concrete here. So therefore, concrete strong in compression, no, but weak in tension, weak in tensile strength. No, that's the reason why we reinforce it with steel. Pero what does the code, no? What does the code say about all of this? No, so let's look at our codes. No, okay. From Section 422 of the National Structural Code of the Philippines. No? So let's read everything one by one. No? So first, okay, uh, we are considering uh, flexure, no? Meaning moment, no? Okay, equilibrium shall be satisfied at each section, no? So each section of the beam, strain in concrete, no, and non-pre-stress reinforcement shall be assumed proportional to the distance from the neutral axis. No? So somewhat this is applicable. No? So somewhat that is applicable. Next, okay, since this is so next, no, at section 422.2.2 point 1, no, maximum strain at the extreme concrete compression fiber shall be assumed equal to 0.003. Next, tensile strength of concrete shall be neglected in flexural and axial strength calculations. The relationship between concrete compressive stress and strain shall be represented by a rectangular, trapezoidal, parabolic, or other shape that results in prediction of strength and substantial agreement with results of comprehensive test. Okay, so those are uh, design options about the concrete section in general. No, so una, no, we've learned that uh, the strain, no, the strain is linearly proportional, no, from the neutral axis. No, so refer to this one. No. Oo nga, no? So, yan, no? So, we have a concrete here, no? And whenever it is being subjected to bending moment, no? Of course, you know that your concrete, no, is being strained in compression, no? So, uh, there is your strain of concrete, no? Which is linearly proportional, no? And measured from the neutral axis, no? The neutral axis, there's no stress that occurs, no, as well as no strain, no? Okay, and the distance from the neutral axis to the extreme compression fiber is letter C, no? Okay, and we all know nga, no? Sinabi ko kanina na ang concrete walang tension. So therefore, on the calculation, walang tensile strength ang concrete. Pero, no? Therefore, mawawala ang tension sa concrete. Pero, of course, ang gagawin natin doon, no? We are going to exchange it with reinforcing steel, no? So kaya meron tayong steel dito, no? Represented by that small circle, although hindi naman necessarily na isang reinforcing bar lang siya, no? And usually represented by uh, total area of steel A sub S. Okay? No? So alam natin na sa ang magiging extreme tension fiber natin from the neutral axis. And the distance from the top compression fiber up to the A sub S is D, or what we call the effective depth. No? So, the next again, yung sa code, no? Meron ang strain of concrete natin merong limit, no? Which is equal to 0.003 only, no? Dahil, no? So at the same time, no, yung kapag na-strain ng concrete when subjected to bending moment, we also know that the steel will also experience strain, no? Mamaya aalamin natin kung ilan, no? Gaano kalaking strain ang mangyayari sa concrete ay sa steel mo, no? Pero we know na fix ang strain limit ng concrete, which is only equal to 0.003. Okay, no? So let's go back to the codes, no? So tutuloy natin yung pagbabasa ng codes. We are going to, no, from section 422.2 2.4, the equivalent rectangular concrete stress distribution in accordance with sections 4.1, 4.3, satisfies 422.2.2.3. Okay? No, so sa 1, concrete stress of 0.85 F prime of C shall be assumed uniformly distributed over an equivalent compression zone bounded by edges of the cross-section and a line parallel to the neutral axis located at distance alpha from the maximum fiber of maximum compressive strain, no? As calculated by alpha is equal to B sub 1 C. Okay? Distance from the distance from the fiber of maximum compressive strain to the neutral axis C shall be measured perpendicular to the neutral axis. No? So going back here, no? We all know, no? We all know that uh, yung stress distribution naman natin, no? Here, because steel na siya, no? Uh, because this is already composite material, no? Combination of concrete and steel, alam natin na hindi na siya kapareho nung natutunan natin from strength of materials. And the stress, no? The compressive stress at the concrete at the compression fiber is already not uniformly distributed, no? Although yung steel, alam natin na uniformly distributed pa siya, no? Pero the concrete is not just the same. So may sinabi si NSCP na yung 0.85 F prime of C or the 28-day compressive strength, no? Can be assumed to be uniformly distributed at a distance A or alpha from the top compression fiber. Okay? No? So, magne-measure tayo from the top compression fiber, bababa tayo ng A, and maa-assume natin na yung rectangular load ng 0.85 F prime of C ay distributed doon sa cross-section natin. So, distributed siya dito. No? So, yan. Okay. No? So, distributed siya here. Okay? No? So, therefore, to compute for the compressive force acting on that section, no, C sub F is equal to 0.85 F prime of C A, no, that is your A and B. No? So sabi ulit sa code, no, the distance A is a fraction of the total compression fiber C. No? So yung A natin is a fraction of C, no? No? So yung C natin, yung total compression fiber, i-multiply lang natin ng B sub 1, no, para maging letter A. Okay? No? So at the same time, simultaneously, kung meron tayong compressive force, meron din tayong tensile force. No? Tensile force is equal to area of steel multiplied by this stress, no? At steel, no? So hindi pa natin alam kung what is the stress of steel, no? Okay? Pero alam natin na usually given ang F prime of C or the 28-day compressive strength of concrete. Okay? No? So, balik tayo sa code. What are the typical values for B sub 1? No? Typical values for B sub 1, no, shall be in accordance with the table. No? So, if F prime of C is from 17 to 28, B sub 1, beta sub 1 is equal to 0.85. From 28 to 55 megapascal, no, 0.85, no, times 0.05 times f prime of c minus 28/7. No? So if f prime of c is greater than 55, your b sub 1 will now be 0.65. Okay? No? So you will just refer to this table if to know that. Okay? No? So, ayun. From that, no, from this equivalent stress block natin, this is your equivalent stress block, no? We are able to derive the following formula. C sub F is equal to T sub F. This is from the equilibrium, no? And if our beam is rectangular, of course, 0.85 F prime of C AB, then equal to AS FS. Okay, next. No? For moment naman, if we do summation of moment at the tensile section, at the tension area, no? M sub n is equal to C sub F, no? Multiplied by D, no? Ang D natin is the effective depth, distance from the top compression fiber up to the steel, no? Minus A over 2. Kasi nga, assume natin uniformly distributed yan. Same way with tension steel, no? T sub F is equal to T sub F multiplied by D minus A over 2 is the nominal moment. And we've learned na yung M sub mu natin is also equal to phi, should be less than or equal to phi M sub n. Okay? No? So, those are ito yung mga derived formula natin, no, from the equivalent rectangular stress block, no? Pero dun sa strain diagram naman, we are able to derive 0.003 over C, no? This one using similar triangles or ratio and proportion is equal to strain S over D minus C. Okay? So mamaya, it depends on the condition what should be the value of your strain S. Kasi yun ang magiging deciding factor natin, no? Depending kung what happened to the beam, no, when subjected to bending moment, no? Okay. So you already know, no, all the basic formulas that we need, no, for both analysis and design of reinforced concrete beams. No? So let me tell you, no, what are the typical design, no? What are the typical design of concrete, no, and what will happen to them, no, when subjected to loads, no? So first, no, we have what you call compression controlled uh, design, no, or yung tinatawag nating over-reinforced, no? So concrete will fail first prior to tensile steel, no? So we know that from this figure, no, failure of concrete will occur when it reach the strain of 0.003, no? Pero our E sub S, no, will fail, no, if the will start to fail if the tensile strength, no, had already reached F sub y. Pero on compression controlled or over reinforced design, no, we have found out that uh, your stress, no, tensile tensile we have found out that strain of concrete will be reached to its limit first bago pa ma-reach ng steel yung kanyang required strain, no? So this is not a good design, no? Over enforced design are not good kasi uh, we won't have any warning, no, kapag sumosobra na yung load natin, no? So bigla na lang magfe-fail yung concrete structure natin, or in this case yung beam natin pag sumobra yung load, no, without any indicator of impending failure, no? Bakit? Kasi pagka naunang nag-fail yung steel natin, no, of course, magbibigay yon ng warning sa concrete natin, no? So, kagaya ng mga cracks, no, hairline cracks, etc. No? So, ang sinabi sa code na the limit of concrete strain is only 0.03, no? If your concrete wasn't able to reach its yield strain or yung ET sub Y, no? Meaning, no, uh, the design is compression controlled. Okay? In kasi, no, our ET, no, is somewhere here. Okay? And this will become your Fs. This will become your ET for over-enforced design. No? And we don't want that. No? Pero, of course, how are we going to find out if over-enforce yung RC beams natin, no? If this one, no? Kagaya ng kakasabi ko lang. O nga pala, no? I'm teaching you first how to analyze beams, no? Before we proceed with design itself. Kasi typically, no? In structural engineering, you should know first how to look kung ano yung magandang design, tsaka kung ano yung hindi magandang design, no? And we know that compression controlled concrete are is an indicator of medyo hindi magandang design, no? Okay, next type of design is yung tinatawag natin na balance condition, no? So this is our balance condition, okay? No? So letter B, concrete and steel will fail simultaneously. Okay? So going back on our graph, no? So the concrete will reach its strain of 0.003, and at the same time, no, steel will reach the yield strength of Fy, no? So ET is equal to sub Y. Now going back to the derived formula, no? Yung dinerive natin using similar triangles, no? So 0.003 over C sub B, ito yung extreme compression fiber, no? Assuming balance condition is equal to strain S over D minus C sub B. Ang ETY natin is equal to Fy over ES. Okay? No? So we know that within elastic limit, no, stress, no, is directly proportional to strain, no? And yun, Fy, no, is your yield strength, no, over 200,000, no, which is the modulus of elasticity for steel, no. So 0.003 is equal over C sub B is equal to Fy over 200,000 over D minus C sub B, no. So we use ratio and proportion, no. We are able to derive this. D minus C sub B over C sub B is equal to Fy over 600. We play with our equation. We are able to solve for C sub B in terms of the effective depth. No? So C sub B is equal to 600 over Fy plus 600 multiplied by D. No? So itong formula to 600 over Fy plus 600 is the multiplier of D in order to obtain your extreme compression fiber. No? So C sub, and we all know na from the strain diagram, no, ang C sub B natin is just a front of the effective depth. If we use the original formula, C sub F, yung na-derive nating formula kanina dito, this one, no, C sub F is equal to T sub F, no? So 0.85 F prime of C B1, no? Times 600 over 600 plus YD B, no? So this is 0.85 F prime of C A B. Ang A natin is equal to B1 multiplied by C. C sub B natin is equal to this one, is equal to uh, area of steel in balance condition multiplied by Fy. Ang ASB natin is equal to 0.85 F prime of CP1 over Fy times 600 over 600 plus Fy PD. No? So some textbooks, no, are saying that this formula, no, is what you call the balance steel ratio. So wait lang. Let me mark this more properly, no? Okay, no? Textbooks are saying that this is what we call the balance steel ratio or ROBAL. Steel ratio pala, RO, no? Sa si NSCP medyo silent about steel ratio, pero some textbooks, no, are using steel ratio as also a variable. No? So this is your balance steel ratio, ROBAL. Okay? So that is in balance condition. No? So the question is the balance condition a good design? No? Still no. No? Kasi nga, ideal design, no? We need warnings or red flags, no, that our reinforced concrete, no, will start to fail, no. And how are we going to reach that? Yun yung tinatawag natin na tension control or the under reinforced design, no. So nga pala, no, if we use before we move on to the transition or tension control, no, we try to derive first mu in balance condition. So using this one, mu is equal to phi mnb. Mu b is equal to phi 0.85 f prime of c b1b, no, times 600 over fy plus 600 b times d minus a over 2. So 1 half b1d 600 over fy times 600. Mu sub b is equal to phi multiplied by 510 b sub 1 f prime of c over fy plus 600 bd squared, no, times 1 minus 300 over fy plus 600 b sub 1. That is your formula for mu in balance condition. Okay? So that one, no? Next type of design is the transition or the tension control. No? Other term would be under reinforced. No? So tension steel will fail first before concrete. Ito yung ideal design natin kasi nga when the steel will fail first, the reinforcing steel, the tension steel, no, gives a warning on the concrete, no, through its cracks, through the concrete cracks, no. So ETY is less than E sub T is less than 0.05. Typical tension control, no, ET is greater than 0.005. No? If ET is equal to 0.005, no, from the formula that we're able to derive earlier, 0.03 over C is equal to 0.005 over D minus C. D minus C over C is equal to 5 over 3. We are able to know that C is equal to 3/8 of D. No? So like what I said before, yung compression fiber C natin is just a fraction of your effective depth. For analysis purposes, no, M sub n is equal to CF times D minus A over 2. MU, o in controlled, is equal to Phi multiplied by CF times D minus A over 2. MUT is equal to Phi times 0.85 F prime of C AB times D minus A over 2. No, so we use the formula that we derived earlier. 38B1D, no? So this one. And we are able to find out that mu sub t is equal to phi times 51 over 160 f prime of c d1 bd squared times 1 minus 3 over 16 b sub 1. So saan ko nakuha pala itong tension controlled? And, no? So let's look again at the codes. No? So ito yung sinasabi ng code natin. Looking at section 421. No? So that is compression controlled, no, are the bad design, no, na over reinforced. No? Transition and tension control are somewhat both good design, no, but until a certain degree only. No? So ang fee natin, if design is compression controlled is equal to 0.65, no? Ang in transition 0.65 plus 0.25 E strain T minus strain T sub Y over 0.005 minus strain T sub Y. If greater than 0.005 natin, tension controlled, no, we can use phi is equal to 0.9. Okay? No? So we go back here, no? So dahil ang tension strain natin is equal to 0.005, we can use phi as 0. Okay, no? So sinasabi dito, no, what should be the maximum uh, moment, no? This is what should be the maximum bending moment, no, in order for the ideal design, no. There's a code from section 409.3.3.1, no. So here it is. So for non-pre-stress beams with P sub U is less than 0.1 F prime of CAG, no? Here are the beams, no, na walang axial load. E sub T shall be at least 0.004. Ibig sabihin, pag mas mataas na sa 0.004 ang tensile strain natin, no? Ang pag mas mataas na siya sa 0.004, no? That is the already ideal line, no? So inassume lang na from here, no? From here, no? Ang strain natin is 0.005 to in order for it to become tension control, no? Pero ang pinaka maximum na strain niya should be 0.004, no? Kapag no, for P sub U, no, is less than 0.1 F prime of CAG. No? If it is equal to 0.004, no, we are able to say that C is equal to 3/7 of D. No? We know that 3/7 of D is larger than 3/8 of D. So, ibig sabihin, pag mas malaki yung strain mo, no? Pag mas malaki yung tensile strain mo, no? Ang ibig sabihin lang nun, no? Mas ideal yung design mo. Okay? For analysis purposes, mu max is equal to VCF times D minus A over 2. Using the same method that we did earlier, no, we are able to derive this formula. No? So, yeah. 51 over 140 F prime of C B1 BD squared times 1 minus 3 over 14 B sub 1. This is your mu max, no? That is within ideal, no? Pero if you want it to be tension controlled, you will have to use this formula, no? As your idea, your moment. It's much more ideal, no? As tensile strain increases, nominal moment decreases. Yan. Et is less than 1/4. Mu is less than Mmax. Okay. No, so, ngayon, marunong na tayong mag-analyze if the beam is designed well or not. No? So, let's proceed with design itself. After the analysis, we are now going to proceed with the design. No, so from what we've derived, C sub F is equal to T sub F. No, 0.85 F prime of C A B, no, is equal to AS F sub S. No, and from your NSCP, no, what uh, what should be the values that we're going to follow. From section 420.2.2.1, let's look at the code again. So section 420. From section 420, we know that, and so 420.2.2.1, the stress below Fy shall be Es times steel strain, and for strains greater than the corresponding to Fy, stress shall be considered independent of strain and equal to Fy. So, ang ideal design natin, we know that our ideal design, should be under reinforced or tension controlled, which is greater than strain that corresponds to yield stress. So, yung Fs natin shall be equal to Fy. So, we are able to derive that 0.85 F prime of CAB is equal to AS Fy. And we found out that your A is equal to B sub 1 multiplied by C beta 1. And we also know that C is a fraction of D, as we found out earlier, when we are deriving formulas, C. So we assume that C is the K fraction of D, K multiplied by D. So we put this on the derived value of A, B1 KD. A is equal to B1 KD. So B sub 1 multiplied by C, B sub 1 multiplied by KD. So we're going to do this. B sub 1 KD is equal to ASFY over 0.85 F prime of C multiplied by beta 1 BD. So we divide them both by beta 1, divide them both by beta 1 times d. No? So, beta 1 d. No? Dinivide ko yung kanang beta 1 multiplied by d. So, i-divide ko din yung kanan ng beta 1 d. So, we can arrange it this way. No? So, k is equal to as over bd multiplied by fy over 0.85 f prime of cb1. No? So, some textbooks, no, say that as over bd is your rho, or yung tinatawag natin na still ratio, no? So if we rearrange it again, no, ilagay natin yung fy dito, prime of c. So if we rearrange it again, this will become your omega multiplied by 1 over 0.85 b1. So ibabalik natin, a is equal to b1 kd, no? So binalik natin, a is equal to omega over 0.85 b1 times b1d. So omega d over 0.85, no, is equal to rho fy over 0.85 f prime of cb1 times b1d. And we are able, and I was able to, we are able to have different methods in designing, no, based on the ultimate moment, no? So pagka given yung moment natin at magde-design tayo, we have four different ways, no? So una ito, mu is equal to phi multiplied by cf times d minus a over 2. Mu is equal to phi and 0.85 f prime of cab times d minus a over 2. Formula 1, formula 2, no? Formula 3, no? Formula 3, no? So express it in terms of omega, no? Omega bd squared times 1 minus 0.59 w omega rather, no? And formula 4, mu is equal to phi rn bd squared. So note, you have to note that Rn is equal to f prime of c omega times 1 minus 0.59 omega. So you have to remember this formula. 1 or then also this one. At you don't have to memorize that if you are just going to design, no? So pero tinuro ko pa so if you're able to solve for Rn, masosolve mo yung rho which is also equal to this one, no? 0.85 f prime of c over a fy times 1 minus square root of 1 minus 2 Rn over 0.85 f prime of c. Okay? So just remember these equations, no? So either 1, 2, 3, or 4. Method 1, method 2, method 3, method 4. Method 1 and 2 are just the same. Pero kasi formula 2, no? We assume that this is already a rectangular beam, no? So yan. Okay, no? So we are going to try this out, no, on all our problems concerning shallow foundation, no? So kayo nang bahala mamili pala, no, kung ano ang gusto nyong gamitin na formula, no? Pwedeng ang gawin nyo ay hahanapin nyo yung rho, no, or yung omega or yung Rn, no, depending on your taste, kung ano yung mas maiintindihan nyo, no? Pero for the sake of discussion only, I will just solve it, no? Pero you have the freedom to choose what do you want to use, no? Except if I specified something, no? Okay. So we are now going to check, no, the minimum effective depth, no, for our footing to be to withstand the moment, no? So we are going to assume, no, that starting from the critical section up to the face of the footing, no, up to the edge of the footing, no, it is a fixed beam, no, with the fixed support starting from the critical section. Pero you have to know that the critical section, no, somewhat depends on the what type of column, no, or wall das yung sinusuporta ng footing mo, no. So let's look at the codes, no. Tignan natin yung mga code, no, kung ano ba ang location ng critical section for MU, no. So MU, no, from 413 section 413.2.7, no, MU at the supported member shall be permitted to be calculated at the critical section defined in accordance with table 413.2.7.1. Okay, if it's a concrete column or pedestal, no, face of column or pedestal, column with steel base plate, no, steel column siya na may base plate, no, halfway between the face of the column and edge of steel base plate. If it's a concrete wall, face of wall, masonry wall, halfway between center and the face of masonry wall. No, so you have to look at it, no, to see where could be the critical section, no. So dahil concrete column tayo, no, the critical section is on the face of the support, no. Sabihin yung fixed support natin is assumed to be at the face of the column, no. So yung x natin is equal to 2.9 minus 0.5 over 2, which is equal to 1.20. Okay? Ang mu natin, no, is equal to, no, the QU, no, which is equal to 384.305 multiplied by 290 times 1.20 squared over 2. So that is WL squared over 2 from your theory of structures. We're able to know that mu is equal to 802.43 kilonewton per meter. No, so ang ideal design natin, no, it should be tension controlled. So therefore, your tensile strain should be equal to 0.005. Now we use the formula that we derived earlier. No, the 51 over 160 F prime of CB1 BD squared times 1 minus 3 over 16 beta 1. No, so ang phi natin is equal to 0.9 because it's tension controlled. B sub 1 natin 0.85, no, kasi siya ay ang F prime of C natin is less than 28, no. So we are able to solve for D minimum, which is equal to 221.55 millimeter, no. So yan yung minimum natin na depth, no, para maging adequate siya against moment, and alam natin na siya ay tension controlled na. Okay, if we compare all the minimum depth, no, doon sa mga na-solve natin before, no, against one-way shear, the minimum is equal to 443.51, two-way shear 525.71, no, for moment 221.55. So ang two-way shear natin gagamitin natin will be yung against two-way shear, which is equal to 525.71 millimeter, no. So kung nga pala, no, let me just tell you na in most cases, no, ang critical na nangyayari sa footing every time na ina-applyan natin siya ng load, usually nasa shear, no, madalang lang sa moment. And yung moment, no, mawi-withstand niya yung moment, no, as long as we have the right amount of reinforcement on the footing, no. So D minimum is 5.71, no. So pansin nyo, no, against one-way shear and two-way shear, no, maliit lang ang D minimum para sa moment. no? So usually hindi na kailangang i-determine yung D minimum, no, against moment kasi usually gagamitin na yung one-way shear or two-way shear. No, so i-explain ko din sa inyo kung bakit. Pero we should recompute the thickness of your footing first. T is equal to 525.71 plus 75, no, which is the concrete cover, no, written from your NSCP, no. So ito yun, no. Andito siya. Okay, no, this one. Okay, ayan. Exposed to weather or in contact with ground, no? Cast against and permanently in contact with ground, no? Minimum concrete cover is 75 millimeters, no? So this one. Okay, doon ang galing ang 75 millimeters natin. Okay? Plus 1.5 times diameter of bar. Bakit? No, kasi the effective depth is the measure from the top of the beam up to the center of reinforcement. Dalawang reinforcement natin, you have to remember, no? So ito yung itsura ng detail niya, paakyat, no? This is uh, top at saka bottom na magkapatong, no? So therefore, we ang nakuha nating D minimum is 525.71, which we can assume located, no, on the top bar, 521.71, no. So pa-plus pa natin siya ng 1, no? So 0.5 ng diameter plus 1 whole diameter, which is equal to 1.5 times 25. Ang minimum thickness natin is equal to 638.21, which can be rounded up to 650 millimeter, nearest 25 mm. Okay, so you may want to check, no, if this can withstand ultimate bearing capacity, no. So you can try redoing the what I've taught you from the first video kung pasok pa rin siya, no. Okay. And that ends our video, no, uh, for some background about reinforced concrete beam and checking the adequacy against moment. No, so next video we're going to design now the reinforcement of our footings, no, to footings in consideration, no. So for any questions, no, don't hesitate to comment below or message me on my social media accounts or send me or you can message me also on Blackboard, no, or and for more announcements, for more updated videos, continue to like and subscribe, no? Okay, thank you and see you next video.